So this is the Chapter 1 practice test in Precalculus on OpenStax. I'll link it in the description below, and I figured I'd do the problems and explain how they're done. So for the following exercise, to determine whether each of the following relations is a function. Number 1, y equals 2x plus 8. Yes, this is a function, and why is this? Because we can pick any value of x as our input, and everything is fine. In terms of number 2, we have the points 2, 1, 3, 2, -1, and 0, 2. In this case, although we have different x values, in terms of our function, we do not have, for example, 1 something. We don't have 1 in our domain. And for a function whose domain is specified, we have to have all values of the domain in our function. So in other words, there's no domain here specified to tell for sure whether or not this is a function. Maybe the domain is only 0, -1, 2, and 3, but the expectation is that you'd have 1 in there as well if we're looking at discrete values. So the intuition here says no, it's not a function. For the following exercises, evaluate f of x equal to -3x squared plus 2x at the given input. So what we'll do is we'll put our value here in for each of these x's. So for f is equal to -2, we get -3 times -2 squared plus 2 times -2. This will give us -3 times 4, which is -12, plus 2 times -2, which is -4. So we'll subtract 4. This will give us -16. For f of a, all we'll do is we're going to put in the value a wherever x is. So we're going to get -3a squared plus 2a. For 5, show that the function f of x equals -2x minus 1 squared plus 3 is not 1-to-1. So basically, what this says is that if x1 is not equal to x2, then f of x1 is not equal to f of x2. In other words, x gives a unique output. So in other words, what we want is for one x value to give us one thing. However, what we see here is that we have a squared involved. So what this means is that we're going to be able to put in two different x values and get the same output. It's just a matter of figuring out which x values that is. So what I know is that -2 squared and 2 squared both equal 4. So if we pick x equals 3 and we pick x is equal to -1, what we're going to get is 2 squared in the case of putting in 3, and -1 gives you -2 squared. So in other words, they're both going to have the same output value, so it's not quite going to work here. Now, in terms of 6, write the domain of the function f of x is equal to the square root of 3 minus x in interval notation. What we have to do here is we have to realize that 3 minus x has to be greater than or equal to 0. So that means 3 has to be greater or equal to x. So in terms of interval notation, this goes from 3 including it up to positive infinity. Given f of x is equal to 2x squared minus 5x, find f of a plus 1 minus f of 1. And then we're going to have a graphing problem. So what I'm going to do in this case is I'm going to take everything remaining on this page and I'm going to shift it over to a new page. We can get rid of, oh, that's going to be part of our thing, our little lines there. So we'll also move this down. Well, we'll keep it there. So for 7, what we're going to do is we're going to plug in a plus 1. So we're going to do f of a plus 1 minus f of 1. So we're going to put a plus 1 in for all of our x's. So 2 times a plus 1 squared minus 5a plus 1. And then we're going to subtract the same thing where we're putting 1 into x's. This is 2 times 1 squared minus 5 times 1. So 2 times a plus 1 squared is going to give us a squared plus 2a plus 1. That's just a plus 1 times a plus 1 and foiling it out. We're going to subtract 5a, we're going to subtract 5, then 2 times 1 squared is 2, so we'll subtract 2, and we're going to subtract negative 5 times 1, so we're going to add 5 to this. So we're going to get 2a squared plus 4a plus 2 from our first bit expanded. We're still going to subtract 5a, but then we're going to get minus 5 plus 5 minus 2. So minus 2 there. Now we'll group up like terms. We're going to get 2a squared. 4a and minus 5a gives us negative a, and then the 2's cancel. So we could simplify this and say that this is a times 2 minus a. Now, we're going to have to graph a function. So why don't we just graph it right where it is up here? It's going to be a little bit small, but that's okay. It's x minus 1 between negative 2 and 3, and negative x for x greater than or equal to 3. So let's use orange here. So at 3 or above, we're going to get negative x. So this means that at 3, x is going to be negative. In fact, what I'm going to do is I'm going to shift this graph up a little bit, because as x gets bigger, this graph is going to get smaller. So it's going to head down in that direction. And then it's going to be x plus 1 between negative 2 and 3. So up until this point at 3, we should be heading towards 4. And then everything after that, we should be going down 1. So at x equals 1, we should be at 2. At x equals 0, we should be at 1. And then at x equals negative 1, we should be at 0. And then x at negative 2 should give us negative 1, but we're not including it. So this should be a straight line, but the way that I've drawn the graph, it's not so straight. So that would be the graph in 8. So next, we want to find the average rate of change of the function f of x equals 3 minus 2x squared plus x by finding f of b minus f of a over b minus a. So we can do this. We're just going to plug in some values just like we did before. So f of b is going to be 3 minus 2b squared plus b. We're going to subtract f of a, 3 minus 2a squared plus a, and we'll divide this by b minus a. So this is going to give us 3 minus 3, which is 0. We're going to get negative 2b squared plus b. We're going to subtract 2 times negative a squared. So we're going to add 2a squared, and we're going to subtract a. So we can do this. Now, what I'm going to do in this case, we still have to divide by b minus a, is I am going to take a b out of our first bit. So we're going to get 1 minus 2b. That gives us b minus 2b squared. And I'm going to add from this, I'm going to take a out. We're going to get 2 minus a, and we'll divide this by a minus b. Now, maybe there was a more clever way of doing this, but this just seems fine to me. B times 1 minus 2b plus a times 2 minus a divided by a minus b. That's going to be the average rate of change for this function. We can break it down more. I'm not immediately seeing it, but this seems just fine. And I put a minus b, but that should be b minus a. For the following exercises, use the functions f of x equals 3 minus 2x squared plus x and g of x equals root x to find composite functions. So if we take g composite f of x, this is just the same thing as doing g times f of x. So this is going to be g, where we plug in 3 minus 2x squared plus x into our function. So in other words, in the square root of x, we're just going to replace every x with 3 minus 2x squared plus x. 3 minus 2x squared plus x. So that will be our composite function. Now we need to evaluate it at 1. So we're just going to put 1 in everywhere we see an x. So 3 minus 2 times 1 squared plus 1. So it's going to give us the square root of, well, 3 minus 2 plus 1, which is the square root of 2. Now in 12, we need to express this as a composite function where f and g together gives us this function. So this is going to be the same as f of g of x. So I want to do something very similar to what we saw before. I want to be able to put 5x squared minus 3x into a function, and I want it to give us our output. So to do this, we're going to pick f of x is equal to the cubed root of x. So that way when we put our g of x in there, we're going to get our big cubic root, which means that our function g of x is going to be 5x squared minus 3x. So those are questions 1 through 12. Let's keep going. Graph the functions by translating, stretching, and or compressing a standard function. So because these are graphing exercises, to be honest, I'm tempted to not really do it at all, but we'll do it. So draw some functions here. So basically we're going to start with the square root of x plus, or just the square root of x, so it's going to look like this. We're going to shift it 6 units to the left, and we're going to shift it 1 unit down. So 1, 2, 3, 4, 5, 6. In other words, let's use a different color for this. Let's use dark blue. It would look something like this. We're shifting it to the left 6 and down 1. Now, if we do 1 over x plus 2 divided by 1, or sorry, not divided by 1, minus 1, what we can do in this case is we can start with the graph of 1 over x. And the graph of 1 over x looks a little bit like this. And now what we're going to do is we're going to shift it to the left 2 and subtract 1. So we have a point here at -1, -1. So this is going to be shifted over 2, and it's going to be shifted down 1. So in other words, we're going to see something that looks like this here. At our point 1, 1, we're going to shift it to the left 2 and down 1. So we'll be left with a graph that looks a little bit like this. So that would be the orange there. Not the perfect drawing, but we should see nothing at that point, x equals -2. For the following functions, determine whether the functions are even, odd, or neither. So to remember, an even function says that f of -x is equal to f of x, and an odd function is f of -x is equal to -f of x. So for 15, I see some x squareds in here. So I'm just going to guess that this is an even function because even powers tend to work very nicely, but we can test this out. So if we put in f of -x, what we're going to get is -5 over -x squared. Add 9 times -x to the 6th. And what's going to happen is these negative x's are going to become positive whenever we do our even powers. So yes, it is even. In terms of oddness, if we do -f of x, what's going to happen is the minuses and pluses are going to switch in this case, and we're not going to get the same thing. For 16, this is not going to be even, because if we put in -x, we're going to get -x to the third, which gives us a -x back. So it's not going to quite work like we want it to. But in terms of oddness, Let's try f of negative x here. So this is going to give us negative 5 over negative x to the third plus 9 times negative x to the fifth. So what's going to happen in this case is we're going to get negatives out of it. So this is going to be 5 over x cubed minus 9 over x to the fifth, minus 9x to the fifth. And if we take the negative version of our original f of x function, what we get is just this function we have already here, but with the signs flipped. So it is indeed odd. Now in terms of f of x equals 1 over x, well, if we put in f of negative x, we're going to get 1 over negative x, which is the same thing as negative 1 over x. And this would be the same thing as negative f of x. So this is going to be odd, but this will not be even because our function here is not the same thing as our original function. So even, odd, and odd. Graph the absolute value function, negative 2 times the absolute value of x minus 1 plus 3. So basically what we're doing here is we're checking values of x. So I could just make a little graph of this. So if x is equal to 0, then negative 2 times the absolute value of x minus 1 plus 3, what's this going to get? So we're going to get negative 2 times 1 plus 3, which would be 1. We put 1 in for x, we're going to get negative 2 times 0 plus 3. If we put in 2 for x, we're going to get negative 2 times 1, which is negative 2 plus 3, which is 1. If we put in 3, we're going to get negative 2 times 2, which is negative 4 plus 3, which is negative 1. If we put in negative 1, we're going to get negative 2 times 2, which is negative 4 plus 3, which is negative 1. So if we were to graph this function, we can put in some labels here. Get 1 here, 3 would be there, and we're going to get a graph that looks a little bit like this. 19, solve. Absolute value of 2x minus 3 is equal to 17. So what this means is that negative 17 is, okay, how we should do this is we should remember that if we have the absolute value of a is, let's say, equal to 2, what this is going to mean is that a can be equal to negative 2 or a can be equal to 2. They're both going to be the same thing here. So with this in mind, we're going to get that negative 17 is equal to 2x minus 3, which is going to be equal to 17. So we can add 3 to both sides. So negative 14 is equal to 2x, which is equal to 20. And we can divide by 2. So negative 7 is equal to x and also 10. So x is going to be either negative 7 or 10. 20 is going to be very similar, but we have a greater than sign. So the negative absolute value of 1/3 x minus 3 is greater than or equal to 17. How are we going to solve this? Well, it's going to be pretty similar. But remember, if the absolute value of a is greater than or equal to 1, this means that a is going to be greater than or equal to 1, and a is going to be less than or equal to negative 1. So, in terms of doing this problem, we're going to say that the negative 1/3 x minus 3, so we're taking that, is going to be greater than or equal to 17, and it's also going to be less than or equal to negative 17. So we'll deal with that one after. So for this one, 1/3 x minus 3 is greater than or equal to negative 17, because we're going to multiply everything by negative 1. But in fact, we forgot to do something here. When we multiply by negative 1, we also flip the sign around. So in this case, we're going to add 3. So negative 14 is 1/3 x. So x is going to be less than or equal to negative 14 times 3, which is negative 42. So up until, so let's just clear this first bit here so we can do the other side. Negative 1/3 x minus 3 is going to be less than or equal to negative 17. So this means that 1/3 x minus 3 is going to be greater than or equal to positive 17. So this one negative, sorry, 1/3 x is going to be greater than or equal to 20. So x is going to be greater or equal to 60. So from negative infinity up until negative 42, we have a domain. And then from 60 up into infinity, we also have our domain. For the following exercises, find the inverse of the function. So what we're going to do here is we're going to change f of x into x. We're going to change all of our x's into y's. So 3y minus 5. And now we're going to isolate y. So x plus 5 is going to be equal to 3y, which means that y is going to be equal to x plus 5 over 3. For this next one, we're going to get x is equal to 4 over y plus 7. So what we're going to do is we're going to say that y plus 7 is equal to 4 divided by x. We're just swapping the x's and y's around by multiplying and dividing. And then what we'll do is we'll isolate y. So y is equal to 4 over x minus 7. For the following exercises, use the graph of g shown in figure 1. So this is the graph that we have. On what intervals is the function increasing? So this is when it's going up. So it's going up from negative infinity to negative 1, not quite including it. And then at 1, it does the turning point. So not quite including 1, but from 1 to infinity, it is increasing. What intervals is the function decreasing? So this happens between negative 1 and 1. The slope is going downwards. Approximate the local minimum of the function. Express the answer as an ordered pair. So the local minimum is going to be this minimum right here, which is going to be approximately 1, negative 1. And the local maximum is going to be this point right here, which is approximately negative 1, 1. Of course, the true maximum and minimums of the function, there are none because they go to negative infinity and to positive infinity. For the following exercises, use the graph of the piecewise function shown in figure 2. So find f of 2. In other words, we're looking at this point right here, the one that's filled in. So f of 2 is just equal to 2. Find f of negative 2. Well, this is the point right here. This is just equal to 2. Write an equation for the piecewise function. So f of x is doing a few things. When x is greater than 2, it's just a constant number, so it is 3. When x is between 0, and I guess we'll include it here, and 2 inclusive, it's just going from 0 to 2. So this is just x itself. It's a straight line. And when x is going from negative infinity to 0, so in other words, x is less than 0, what's happening is it's still an x graph, but the slope is negative, so this is just negative x. For the following exercises, use the values listed in table 1. So we want to find f of 6. Well, this is just going to be 13. We're just taking a look at this number here and giving us f of 13. Solve the equation f of x is equal to 5. So we're looking for the output where f of x is equal to 5. So this is just going to be x is equal to 2. Is the graph increasing or decreasing on its domain? Well, the x values are getting larger and f of x is getting larger. So this is going to be increasing. Is the function represented by the graph 1 to 1? So every single x value is going to give us a unique f of x value. So the answer to this is yes. In other words, unique x gives us a new y, or what we would say here is an f of x. Find the inverse of 15. So what this means is, well, we're not trying to solve. Okay, so let's just remember this. So if we take the f inverse of x is equal to y, this is just saying that f of y is equal to x. So f inverse of 15 equal to x is basically just saying when does f of x equal 15? And this is going to be, in this case, when x is equal to 7. 35 is the final question. Given f of x equal negative 2x plus 11, find f inverse of x. So this is when we have y equals negative 2x plus 11. We're going to swap the x's and y's. So x is equal to negative 2y plus 11. So now we just need to isolate y. So x minus 11 equals negative 2y. We're going to divide each side by negative 2. So this will be x minus 11 over negative 2 is equal to y. And if we want, we can simplify this a little bit. Say 11 minus x over 2 is equal to y. So that's it for the Chapter 1 practice test. I know some of the questions were kind of squished, but this was the reasoning of how we can get through all of these questions and how to solve them. If you have any questions, you know what to do.